I am an astronomer. I work at the University of Oxford, and I don't spend much of my time doing astronomy. I work as a part of a collaboration of researchers and educators and web developers who have built something called Zooniverse, which I will try and explain. We don't just exist at the University of Oxford. We also exist in Chicago, Minnesota, Portsmouth, and a couple of other institutes around the world. And this is one of those stories that's very typical in the cloud, where a good idea was had and it just kept expanding. So hopefully the clicker will click along to the next slide. You have to double click, okay. So you don't click by accident, yes. Right, these are galaxies, and as astronomers, we have to deal with galaxies a lot. Some of them are beautiful, swirly things, that's a technical term, called spiral galaxies, and you can see lots of those in these pictures. And some of them are blobby round things, not quite so technical. We call those elliptical galaxies. And this is a problem for us because we used to have just a few galaxies that we could see. Back in the sort of 70s and 80s, we would take a picture of a galaxy, a professor would receive the picture and say, I declare this a spiral galaxy, we shall study it. Unfortunately, robotics improved, telescopes improved, and before too long, we were getting tens of thousands of galaxies. And in about 1996 or so, we built a thing that got us millions of galaxies. And in 2007, a PhD student in Oxford, let's call him Kevin, because that's his name, he was told to look through a database of galaxies. Here you go, Kevin. Here's a database. I imagine they handed him some kind of printed database. I don't know what they gave him, but it was old-fashioned. And they said, look through it and find us all this very particular rare kind of galaxy. And so he said, OK, because he's from Switzerland. He's very, very organized. He was very good at this. He's a professor now, by the way, so he wasn't harmed in the making of this story. And so he started looking through them, and he spent a week doing nothing but look through galaxies exactly like these, saying whether they were elliptical or spiral. Because a computer couldn't do that for him, and he needed to get it done. So at the end of the week, he'd done 50,000 galaxies, and he was in a pub drinking heavily, and he said, I can't really keep going, and I've only done 50,000, and there's 1 million in the database, and I've found like 5 of these weird galaxies. What shall we do? So him and some friends, inspired by things like SETI at home and Stardust at home, these kind of crowdsourcing distributed computing projects that had existed in sort of 2000, 2004 and such. This was 2007. They made a website called GalaxyZoo. And GalaxyZoo simply showed people one of these galaxies and asked them if it was spiral or elliptical. And this is the first 48 hours of GalaxyZoo's life. You've got hours running along the bottom, and you've got classifications per hour up on the side. And so Kevin did 50,000 classifications in a week. And you can see that after 2 days, we were doing 50,000 classifications an hour, which is a lot faster than Kevin, thankfully. And Kevin was pleased, of course, because he didn't have to do it anymore. You might notice on this graph, though, the first 7 hours were not exactly our finest. We hosted this on a server at Johns Hopkins University, because that's where the images already were. We were astronomers, so we said, oh, it'll be fine. And then we went on BBC Breakfast and the Today program on Radio 4 and CNN and told the world to go and do this thing, which they went, oh, yeah, we'll do that, we'll help you. And everything broke. And so, thankfully, a sysadmin at Johns Hopkins got up in the middle of the night and fixed everything for us. Otherwise, we wouldn't be here today, and got it running. And you can pay your way out of that problem, right? You can just get a bigger server and employ some more people and make them do it. But it's much more sensible to figure out, as we did about a year later, that we should just use this cloud thing everyone's talking about. We do all this for a great reason, not just because we can do it fast and go on BBC Breakfast and things like that. We do it because we get lots and lots of people to look at our data. Every single galaxy in that database was seen by about 40 different people around the world. Telling us whether it's spiral or elliptical isn't hard. You don't need a PhD in astronomy to do that, and it seems almost wasteful to make all the PhDs in astronomy be the ones who do that. And so 40 random people from around the world can look at every galaxy, and they can give us their opinion. Some of them will say it's spiral, some of them will say it's elliptical, and because of that, we get this statistical response to everything in our database. That's brilliant. We can get humans to do the things computers can't do. We can do it at scale, and we can do it very, very fast because people like science. They like to take part in it and do something fun. So GalaxyZoo still exists. You can try it today, although it will look a bit different. We've had 400,000 people take part in this. They've done hundreds of millions of classifications now. We just keep finding more galaxies to put through this engine. And what happened was GalaxyZoo was rapidly joined by other websites. Other people at the university and in other universities came to us and said, we want to do a project too. So before long, we had one counting craters on the surface of the moon, and we had one tracking storms from the sun as they are catapulted toward the Earth, which, by the way, happens really quite a lot, and you don't want to worry about it, but the first thing that goes is electronic infrastructure. So you probably want to be in the cloud, ironically. These three projects, once we had these, we decided we just needed a name for the whole thing, and so we coined Zooniverse. And that is now a family of more than 30 projects that all do different things. We have penguins, we've got little nematode worms that have cancer. We have papyri, fragments of papyri that we can look at and get people to transcribe, all using the same principles of crowdsourcing and all done through cloud infrastructure, which is wonderful. So we've got 1 million volunteers around the world. They put in an astonishing 50 years worth of effort every year. So collectively, they're a powerhouse, and that's 50 years of non-stop effort. We're not letting them sleep or go on a holiday or anything. So it actually works out to having a sizable office just clicking all the time. And the important thing for us, we've got more than 80 peer-reviewed academic papers now directly from our projects. We also have a whole host of open data that's out there for the community to use, and they do. So let me just show you 3 other examples of projects that we have, just because this is fun, and I have a stage and a microphone, so I might as well. Old Weather, I will start with. Old Weather is a project where we get people to look at handwritten ship's logs from many, many years ago. And in the original case, it was from the Royal Navy around the time of the First World War. And these ship's logs are important because not only do they record the events that happened on board every ship in the Royal Navy, but all the officers were told to 6 times a day measure the air temperature, sea temperature, the wind direction, speed, the air pressure. And all of that was done with a calibrated and consistent set of barometers and other instruments that they were all trained to use in the same way. So as they sailed around the world, they mapped the climate of the world 100 years ago. And that's data that's locked away in these handwritten records, which, lovely though the handwriting is, escapes modern optical character recognition. So we got people to look through this. They went through 1 million of these pages for us, and they mapped the world's climate. And these data go into the Met Office climate simulations that determine all sorts of things about climate patterns and long-term changes in the climate. The reason people did this, though, was nothing to do with numbers, I don't think. It was because as you're doing it, you get to read all the things that happen on the ship. And so we've got things here like leave for boys until 1 p.m. until Mrs. Smith has finished with them. I don't know who she is. We've got a lecture by the captain, subject the evolution of man. And then down at the bottom there, 11:45, orders to commence hostilities against Germany received. Not forgetting that this all occurred during the First World War, one of the most interesting parts of history, and certainly in this part of the world. And so people were quite addicted to following these ships as they sailed around. The results are pretty incredible. This is a map of the air pressure. Color-coded dots here, the colors for the air pressure. Roughly, paler, the better the weather. And these are all individual log pages flashing up, because for every log page, you get a latitude, a longitude, all the details about the weather. And the war's about to kick off, so you'll see the fleets come alive. There we go. And ships cover the world. They cover the oceans, the one place where we don't have weather stations, really. And this is all predating satellite technology by a good half a century. Giving the Met Office the kinds of climate data they've been longing for ages. So this is carried on. This phase of the project's completed, and we now do different parts of ship's logs from around the world. We're currently looking at the Arctic Circle near Canada in whaling ships records. It's really addictive watching that video. So more up to date in one sense, this is a newer project, but from the same era, Handwritten War Diaries. These were given to us by the National Archives here in London, down at Kew. And we are doing this in partnership with them and the Imperial War Museum. We're getting people to come along and tag and transcribe all the names, the events, and the places in handwritten war diaries from the Western Front. And so we're reconstructing a sort of social graph of the First World War. And we're doing that by getting volunteers to come along and help us. And that's ongoing at the moment. It will go on for another 3 years. It launched just earlier this year. But we do have some results. This is a map of fatalities in Western Europe. These things flashing up whenever a fatality occurs. We can reconstruct major events and battles and find other places as well where perhaps we didn't realize so many things were going on. We can do this not just for fatalities, which is a kind of striking example, but we can do it for all sorts of things like the weather and whether people had boots and whether people were serving with other people they knew. They seem to write about that a lot. There's all sorts of things we can dig out of this data once it's extracted from the handwritten records. You'll notice there's some weird things going on up in Newport every now and then. I've never understood why. Finally, an example that will take a second to load from the Serengeti. So these are images from camera traps in the Serengeti, automatically triggered when animals walk past them. Now, these images are laid out in a grid across the Serengeti, and the idea here is that between 225 cameras spread over an area, that's actually a very large area, actually. It's, I was trying to think how big it is. It's comparable to, say, the size of Oxford, at least, which is where I'm from. And we can track animal species as they move around. We get people to tell us what the animals are and what they're doing. And it's just immense fun to look at these animals doing all these fun things. It's a job very ill-suited to computers. Whereas you and I can say, oh, it's a zebra rolling around on the floor. That's nice. Computers don't get that at all. And so this is one of those tasks that's pretty brilliantly suited for human beings. We show people the pictures. We say, you've got to figure out what the animal is. And once you've figured out the animal, you have to tell us what it's doing so that they're eating, they're resting, they're interacting, which is what two animals do when they love each other. You had to come up with something. It happens a lot, apparently. And this has been a roaring success, and we've managed to map out whole new aspects to ecology and computational ecology as well, which is really, really amazing. Why does this work? It works because people have the time to spare. In just the US, people spend 200 billion hours watching TV every year. The human race alarmingly spends 16 years playing Angry Birds every hour. I've lost 2 weeks to Angry Birds, so I'm not really one to judge. And for example, and this number's out of date, and I'd love to know how out of date it is already. It's a few months old. 33 quadrillion bullets have been fired in Call of Duty, which is a lot of bullets. And this is the sort of thing that people love doing these things, but they are also very willing to come along and participate in research when we ask them to. And they can do that at scale without us losing sleep over it, because we don't host everything in Johns Hopkins anymore. We get one other thing just to mention for free. The web is really about connecting people. And when you connect people together, you get some interesting results out of it. So we get all the things we plan to get out of our citizen science projects. We get people to tell us the morphology of galaxies, and we get to know where all the animals are in the Serengeti. But we also get surprising serendipitous results that we didn't expect. Like this picture here was seen by a Dutch school teacher called Hanny van Arkel. She was asked to classify the galaxy, but understandably wanted to know what the blue thing was underneath the galaxy, a question no computer or indeed professional astronomer had asked ever. And in 2008, she asked, what's this thing? And it turned out we didn't know. And we've spent years observing this thing, and it turns out to be an almost unique object in the universe. At the time, it was a unique object. It's a very specific thing called a quasar light echo, which I won't bore you with the details of. But once we'd found it, we realized that, well, we've got 1 million galaxies in our database. We should be able to find some more of these. So we just asked the volunteers, and they found 40 more over the course of a few months. So a whole new category of astrophysics emerged because people on the internet were willing and able to participate and were connected together. And similarly, those old weather logs books with all the weather records written in them, we asked everyone to jot in all the climate data, but they voluntarily started jotting in health data. So they started to jot down the number of people that were in sick bay on any of these log pages. And the result are graphs for every ship showing you how many people are ill, which might not seem like much, but when you look at graphs like this is HMS Africa during 1918, and you'll see that there's an enormous spike. Everyone on the ship, out of a crew of 600, nearly 500 of them are ill in the summer of 1918. This is the Spanish flu epidemic that occurred at the end of the First World War, rediscovered serendipitously by people on the internet, which is great fun for us. So we have serendipitous results in lots of our projects, and they range across topics that I haven't really got time to show you all about today. We have been changing a lot about the way our infrastructure works recently. We host all these projects as HTML-only websites in S3 buckets. It's all backed by currently an ever-changing infrastructure. We used to just have everything on on-demand EC2 instances, but that apparently was not very cost-effective. So we started to change the way we do things and moving to using things like CloudFront in order to deliver things around the world. And we're very excited to keep growing. We're building lots of new platforms. We're making it easier for people to build these projects on our infrastructure. And if you want to join in, then I welcome you to do so. Go to zooniverse.org, pick a project and have a go. And I shall be here this afternoon if anybody has any questions. Thank you.